All right, let's go over lesson 4, practice problems. Go through each one. I'll show you how to use the notation as we go through, and I'll try to help explain the difference between some of these problems. All right, in this problem, the table shows the results of a survey that asked 100 adults if they had a high school diploma and if their annual income was more than $30,000. So notice, first of all, that this table does not have a total row. You are welcome to make one every single time, a total row and a total column. To help you with that, and it's a really good idea to total everything up, so you have each total in case you need it as you're working through. So if I total these up, 30, 70, 30 and 70 makes 100, and that's good because they said 100 adults. If I total them across, this will be 11, this will be 89. And so those totals are good to have, just in the off chance that we need them, depending on what the question asks us. Okay, so first question. A person who took the survey is selected at random. What is the probability that the person has a high school diploma and makes 30,000 or less? So if I see an and here, that means I'm looking for both of those things happening at the same time. So I'm looking for the probability, so P for my notation, that someone has a high school diploma, high school dip, and they make 30,000 or less. So I'm going to say 30K or less. So really this just kind of follows what I'm seeing in the question, and I kind of organize it that way to match. All right, so people who have a high school diploma are in this first row, and the people that have a high school diploma that also make 30K or less are in this column. So people who are doing both are these 21 right here. And so since it says a person who took the survey is selected at random, we're looking out of these 100 people who took a survey. So 21 out of 100. Then I want to do my decimal. It's going to end up being 0.21. For part B, what is the probability that the person has no high school diploma and earns more than 30,000? So now I'm looking at the probability that they've got no high school diploma and they have 30K or more. And so we're still selecting anyone who took the survey at random, so it's still out of 100. But I want to focus on the no high school diploma, 30K or more. I want to focus on these, only 2 people. So 2 out of 100 is 0.02. And so I don't need to go to percents because these questions just asked me for the probability. So after that, I'm all set. All right, let's look at number 2. This table shows the data from a science fair experiment that studied the number of eggs that hatched at 3 different temperatures. So again, there's no total row or column here. So I'm going to just total things up real quick. So here we looked at 75 total eggs. I totaled these up this way. That worked out nicely, 25, 25, 25. All right, so what percentage? So here, look, notice they're saying percentage. I got to answer find at the end with a percent. I'm going to do everything I did here. I'm going to write the notation, get my fraction, get my decimal, and then convert it to a percent at the end. So what percent of the eggs hatched? So I want percent or probability that they hatched. So that means I'm looking out of all the eggs, out of 75, how many hatched? So it'd be 43 out of 75. And when I divide that out on my calculator, I get 0.573. So this is 0.57 times 100, get my percent, 57%. So I want to have all 3 pieces. I want to have the notation, the fraction, the decimal, times 100, or multiply by 100 to get 57%. And each of these, A through D, all say percentage, so I've got to do that every time. For B, they want to know what percentage of the eggs that were at the cool temperature hatched. So I'm focusing only about the eggs that were at the cool temperature. So that's out of those 25. So I'm looking out of the cool. And based on this section of cool, these 25 right here, I'm only wanting the ones that hatched. So I'm looking for hatched out of the cool temperature eggs. There were 25 cool temperature eggs, 6 of them hatched. So I'm looking at 6 out of 25, which is 0.24, which when multiplied by 100 is 24%. So 24% of the cool temperature eggs hatched. What percentage of the eggs were not at room temperature? So I'm just going to say probability of not room. So what percentage of the eggs, meaning the total eggs of 75? So out of those 75, how many were not room temperature? Well, 50 of them. 50 were warm and 50 were cold. So that's 50 out of 75 were not room temperature, and that's 0.33. Oh, sorry, 0.67. It's 0.66666666, but that would round up to 0.67. And then multiply by 100, 67%. And then lastly, what percentage of the eggs were at room temperature and did not hatch? So again, we're looking at the eggs in general. We want at warm temperature, warm and not hatched. So out of all the eggs, there were 75 eggs. How many were in warm temperature and didn't hatch? There were 2. So 2 divided by 75. Divide that in my calculator, I get 0.2, so sorry, 0.02666666, so that's 0.03, which when I multiply times 100, that is 3%. Okay, make that a little clearer. So 3% of the eggs were at warm temperature and did not hatch. Make sure you're using your notation. Make sure you're writing your fraction, your decimal, multiply by 100 to get your percentage. Lots of people are just randomly putting percentages on all of their work, and that's not what the question is asking, so we've got to make sure we're answering it correctly. All right, question 3. This table shows information from a survey about resting heart rate in beats per minute, which is BPM, for 50 people living at altitudes above and below 10,000 feet. Create a two-way table that shows the relative frequency for each of the values in the table relative to all 50 people in the survey. So that is when we change this two-way table into decimals by dividing every cell in here by the total, which in this case is 50. So divide by 50, divide by 50, divide by 50, write the decimals, divide by 50 all the way through the entire table. So I just pull out my calculator. Let me remake my table here. Okay, so I'm going to go through and divide 3 divided by 50 in my calculator, get 0.06. 16 divided by 50, 0.32. 19 divided by 50, 0.38. Again, 19 divided by 50, 0.38. 12 divided by 50, 0.24. 31 divided by 50, 0.62. 22 divided by 50, 0.44. 28 divided by 50, 0.56. 50 divided by 50, 1. So that's how we make our relative frequency. That's the whole table, if you're looking in your notebook. The whole table one that we did. So only the corner will add up to 1. I'm going to use this to answer these next two questions. What's the probability that a person surveyed, selected at random, so out of everybody, has a heart rate above 80 beats per minute or lives above 10,000 feet? So I want the probability of above 80 or above 10,000 feet. So out of everyone, if I'm looking at or, and this is something that we just hit more on when I was looking at, when we looked at lesson 6. We haven't completely practiced it, but this or, we keep getting struggling with this or. So it's the 80 people and the above 80 and the above 10K. So if I look at the above 80, 62% is in the above 80 category. If I look at the above 10K, I've got 44% above the 10K. But this includes 0.06 and 0.38. When I add up these ones, it's 0.38 and 0.24. I don't need to count the 0.38 twice, so I'm really just going to add up the 0.06, the 0.38, and the 0.24. So let me do that real quick. 0.06, 0.38, 0.24. Total those up. And I got 0.68. So I don't actually even need a fraction here. Not asking for a percentage, it's just asking for a probability. So you can say 0.68 is our probability. If I wanted a percent, it's 68%. So I took the things that were in the row that were above 10K and the things that were in the column above 80, and I added them up, making sure I only add each one once. The second question almost looks exactly the same, except for notice it says and here. So that's different. I want the ones that were specifically above 80 and above 10K. So only the ones that do both at the same time. So I'm looking at above 10K and above 80. The only ones that do both at the same time are these 0.38. So that probability is 0.38, 38% chance of someone having above both of those things. All right, let's keep moving. List all the possible outcomes for spinning the spinner and rolling a fair number cube. So remember, if I'm spinning my spinner, I got X, Y, Z as my options. If I'm rolling a fair number cube, I have 1, 2, 3, 4, 5, 6 as my options. So I need to take X with each one of those, Y with each one of those, Z with each one of those. You might look at this and say, okay, I don't need to fill in the boxes. I can just list the outcomes from this. I can say X1, X2, X3, X4, X5, X6, same thing with Y. So that's an example where you might set up your table just to help you organize, but then you don't actually need to fill in the table. That might be a waste of time because we can just go through and make their organized list by looking at the table and realizing a simple pattern I can follow. So I've got 18, 6 of each one, 18 outcomes. And that's what I want. When it says list, that's what I want you to do. List them all out, whether you use a table or not, whether you set up the table to help you organize them, and then you list them out by following what you see in the table, whatever works for you. That's why we have these methods on how to do it. All right. A student flips a fair coin and then spins the spinner. How would you find the sample space? So you could say, you're going to describe here. How would you? So I'm going to make a table with X, Y, W, Z on the rows. And let's see, I'm flipping a fair coin. So maybe actually I might want to have it tails and heads on the row. and then my WXYZ on the column. And then you're going to match up tails with each one of the outcomes from the spinner. So WXYZ will each get a tails, and WXYZ will each get a heads. So it'll be a total of 8 outcomes. So I was looking for you to describe how. Not to actually do it, but to describe in words how to do it there. You also could say, take each outcome in the spinner and put tails with it, and then do the same thing and put it with heads. So whatever makes sense to you to describe how that works. Select all of the words for which the probability of getting a letter A at random is 1/4. All right, so looking at A, probability of getting an A is 2 out of 4 for this one. I don't want that one. Probability of getting A in the next one is 1 out of 4. So I'll choose this one. For angry, it's 1 out of 5. For appeased, it's 1, 2, 3, 4, 5, 6, 7, 8. 2 out of 8, which is 1 out of 4. So I want that one. For aardvark, 1, 2, 3, 4, 5, 6, 7, 8. Probability of getting an A is 3 out of 8, which is not 1/4. So only B and D on this one. All right, last question. So we didn't have to do this one here. Number 8, cross that off. But let's look at number 7. This was a toughie. On an assignment, there are 2 multiple choice questions with 4 answer choices each. You have no idea what the correct answer is to either one, so you guess. You need to think about what the sample space looks like. And this is what I wrote on most people's papers when we went over this. So I have a choice of A, B, C, or D for the first question. Only one of those is right, obviously. For the second question, same thing, A, B, C, or D. And so my sample space is going to look like I could get A on the first one, A on the second one. Or I could get AB, or I could get AC, or I could get AD. So that means the first one I chose A, the second one I chose A. The first one I chose A, the second one I chose B. I also could get BA, BB, BC, BD, or CA, CB, CC, CD, DA, DB, DC, DD. So that's 16 different options. Let's use those 16 different options to help us answer this question. What is the probability that you get both of them right by guessing? So let's just do it for instance. If, let's say, A is the right answer for the first one and B is the right answer for the second one, the only time I'm going to get AB, I get one option out of these 16 to get AB. So that would be getting this one right and getting that one right. There's only one time out of the 16 that happens. So we can say probability of both right equals 1 out of 16. There are 16 outcomes, and if A is correct for number 1 and B is correct for number 2, AB only shows up once in the sample space. Okay. Let's see, what is the probability that you get exactly one of them right by guessing? So let's follow that same thing that I said before. If I want only one of them right, I got one of them right here. I got both of them right here, so I don't think I want to count that one because it says exactly 1. I'm not going to count that one. I got one of them right here. I've got one of them right here. So there's 3 options where I get the first question right. But then following this column, there's also 3 options where I get the second question right. So 6 out of the 16. So probability of exactly 1 right would be 6 out of 16. There are 3 outcomes where only A is correct for number 1, and 3 outcomes where only B is correct for number 2. We cannot count A, B, because then both are correct. There we go. There's one way of saying that. So using that same example where A is the correct answer for number 1 and B is the correct answer for number 2, we've only got 3 instances where A would be the only one being correct for the first question, and 3 instances where we got the first question wrong and the second question right, having a B. So it would be a total of 6 out of 16. But without creating that sample space, a lot of people thought there were only 4 in the sample space or only 8 in the sample space, thinking that there's an A, B, C, D and an A, B, C, D, but you have to look at it with how does this one cross with this one, because if we don't look at it that way, then we wouldn't have realized that there were 16 outcomes. And then that obviously makes us get our probability incorrect. So again, sorry this video was so long, but hopefully that helped make everything make sense. Please let me know if you still have questions, and good luck on future practices.